everybody, welcome back to our series. So far we've taken you through a lot of different systems in the power plant, but today we have a unique experience to film in a room not often seen. It's the brain of the operations, the control room, and here with us we have a 23-year veteran, Bob Crain. Thanks for joining us today, Bob. What can you tell us about the control room?
Well, the control room is basically exactly what the name entails. It's the control center for the entire power plant. The control room operator is charged with the responsibility of monitoring everything in the control, in the entire power plant. The safety of everyone is first and foremost his responsibility. Safety of equipment, dealing with everything from plant casualties, fuel feed events, and essentially just running the day-to-day operations of the power plant.
So you've walked us through the steam cycle and a couple other processes in the plant. What is your most challenging task that you have to do?
Well, as far as challenging, I guess the way you could put it, if you talk to anyone who's been in the power industry for a while, power plant operators, and they've operated a biomass power plant and then moved on to another facility, whether it be a gas plant, a coal plant, or any other type, hydroelectric. Well, they'll all basically tell you the same thing, that if you can operate a biomass power plant, you can operate any power plant. There's just such a caveat of challenges thrown at you on a day-to-day basis. Your fuel source consists of a mixture of different types of fuel, and none of those fuels really burn at the same BTU value. So when you're burning them in the combustor, your fuel feed rate is constantly changing based on the demands of the unit and the BTU factor involved in that fuel. So you deal with a lot of swings, a lot of upsets. It really keeps you on your toes. As far as the most challenging part is most likely if you get a major fuel feed interruption and you lose your fuel feed source to the boiler. You have natural gas that you can utilize to stabilize that flame when you lose your solid fuel. But the most challenging part in that is your environmental aspect. When you upset the process with a huge fuel change like that, what it'll do, it'll knock loose a bunch of ash and whatnot that may actually overwhelm your electrostatic precipitator, and it'll give what's called opacity. It's visual particulates that'll leave the stack, and there's environmental regulations that limit the amount that you can do, and you don't want to exceed those limitations for numerous reasons. So making that transition as smooth as possible and without exceeding any of your environmental limits is a real challenge.
So when you talk about those challenges, is that something you can see right here in the control room and monitor or operate right here?
Oh, of course, pretty much everything that goes on in the plant, you can see it in one form or another from this room. You have a series of pages you can go through that have the different parameters, the different values that you monitor on a minute-by-minute basis. Your emissions will be, we call that the boiler and gas page, that graphic. And on that graphic you have all the data that's being, like the levels, the steam flows, the pressures. In the top right corner would be where your emissions values are, your CO, your NOx, the conductivity in your cooling water is also monitored. And then of course the opacity, which I spoke about earlier, it gives you the minute average on that page. If the plant were online, the page next to it would actually have the real-time opacity. So you can monitor what that opacity is in real time and make adjustments to your airflows and whatnot based on what you're seeing there, so you don't exceed.
Very cool, yeah. So the communication between the plant and the control room is instantaneous, and it's always going.
It is, yes.
And what's the most rewarding part of your job?
I think going back to when I first started out, as a control room operator. One of the most rewarding parts is just the amount of responsibility that you have. That you basically are in charge of this entire facility while you're the CRO. Everything is under your control. And I can remember back to when I did my first plant startup. Now, in a biomass power plant, that's a pretty lengthy procedure. From cold iron to full load takes about 12 hours. So if you start that startup at the beginning of your shift, because I believe by the end of your shift you could have the plant at full load. And I'd say one of the first times that I did that and started the plant from cold iron to full load by myself on shift I went home that day feeling really good about myself.
Yeah, I can imagine that's a really rewarding feeling. You took the plant from not running to fully running. It's amazing. Well, thank you so much, Bob, for sharing your expertise with us, and thank you so much for watching. In the next video, we're going to show you the final step on how to convert wood to electricity.